Hi all, welcome to my channel. This is E. Manjula, lecturer in Electrical and Electronic Engineering, Government Institute of Electronics, Secunderabad. So today we will discuss about the special motors and how many types of special motors and working and its applications. Okay, so the types of the special motors are here. That is AC series motor, universal motor, stepper motor, and shaded pole motor. The last session we have discussed about the single phase induction motors, where shaded pole is one of the single phase induction motor. It is also a special motor. Fine, we'll discuss about the first a special motor, that is a stepper motor. A stepper motor is an electromechanical device which converts electrical pulses into discrete mechanical movements, and the shaft or spindle of the stepper motor rotates in discrete steps increments when electrical command pulses are applied to it in proper sequence. Okay, so you can see here this is a stepper motor. So the stepper motor, it is an electromechanical device. Okay, so it will act according to the pulse input which is given to the motor. So what are the main features of the stepper motor? The sequence of the applied pulses is directly related to the direction of motor shaft rotation, and the speed of the motor shaft rotation is directly related to the frequency of the input pulses, and the length of the rotation is directly related to the number of input pulses applied. So entirely the machine will perform according to the input pulses. So stepper motor characteristics: open loop. The motor responds to digital input pulses, provides open loop control, making the motor simpler and less costly to control it. In brushless, it is brushless and it is very reliable since there are no contact brushes in a motor. Therefore, the life of the motor is simply dependent on the life of the bearings. So, incremental steps and changes. The rotational angle of the motor is proportional to the input pulses. So speed increases, torque decreases. Here, these are the characteristics. So we'll see how torque versus speed characteristics. In the before slide, we have seen that the speed increases and torque decreases. So both are inversely proportional. So torque varies inversely with speed. Current is proportional to torque, and torque is infinity means current is infinity, which leads to motor damage. The torque thus needs to be limited to a rated value of motor. So see here, this is a torque and this is a speed. So torque need to be limited. Here, this is a rated torque. If you cross this, the motor will damage. Means crossing the torque is nothing but you're providing a more current to more rated current. I mean, other than rated current we are giving. So, due to that, the torque will be high because the torque is directly proportional to current. So, as the current increases, torque increases. So, we have to operate any motor to the rated values only. Okay. So, here if you see, so this is a when speed is going on increasing, torque is decreasing. And this is for a single supply and this is for a double supply voltage. So, and the torque will depends upon even voltage also. So that is why the graph is changing here. This is only the, so this is ideal versus practical motor. Okay. So what might be the disadvantages of the stepper motor? Okay. There are two main disadvantages of the stepper motor. First is resonance can occur if not properly controlled. Okay. So this can be seen as a sudden loss or drop in torque at certain speeds which can result in missing steps. So here actually the motor will rotate step by step, one step, two step, three step, four step, like that. So it will rotate in the step by step. Hence that motor is called stepper motor. Okay. So here due to the resonance there is a chance of missing the steps or loss of synchronism also. Okay. So it occurs when the input step pulse rate coincides with the natural oscillational frequency of the rotor. So resonance can be minimized by using half stepping or micro steppings. It is not easy to operate at extremely high speeds. So these are the two main disadvantages of the stepper motor. So we'll see the working principle now. Here the stepper motor consists of a permanent magnet rotating shaft called the rotor and electromagnetic on the stator. So the portion which surrounds the motor called the stator. I can say that the portion which surrounds the rotor called the stator. Okay. So when a phase winding of a stepper motor is energized with a current A, magnetic flux is developed in the stator and the direction of the flux is determined by the right hand rule. So we know when the current is supplied to any winding, then there will be existing of the flux and how the flux will be flown is given by the right hand rule. Okay. So this is indicating the flux, current, and this all other four fingers are indicating the. But in this picture, these are the currents. Okay, all four fingers are indicating the currents. See here, it is a conventional current, and this thumb is indicating the pole's direction. Okay. Okay, fine. See, there are here some positions. This is a position 1 and 5. This is 2, 3, 4. Okay. At position 1, this is on. So here if you observe, see, we know that there is a permanent magnet at rotor. This is a rotor. And these are stator. And the stator magnets are electromagnetism. Okay. So there are stator winding. So here we will energize each and every stator winding one after the other. So this will be energized. So this will act magnet and others will be they are unmagnetized. Okay, only this is a magnetized. Okay. So likewise, we will see the each position. Okay. So at position 1, the rotor is beginning at the upper electromagnet which is currently active. So this here. Okay, has so we have applied voltage on it. If you observe plus or minus, only we have applied the voltage to this circuit. So when the current passes through this coil, this will act as a magnet that is called electromagnetic. And to show the rotor clockwise, the upper electromagnet is deactivated and the other right electromagnet is activated. That is here. So this is first activated. So here this is first activated and then this is here second activated. Okay. So electromagnet is activated causing the rotor to move 90 degrees clockwise aligning itself with an active magnet. So here this rotor is moved here if you observe. Okay. So what's happening? We know that at position 1 north and south pole are opposite poles, so attract each other. So here it will become a magnetic locking will occur. Okay. So when the supply is given to the north and south pole and we will make this off. So simultaneously we will give the supply to the next circuit and the present circuit the supply will be cut off. So what happened? So a there will be a change of this rotor position from here to here as there is an attractive force here. So there will be again a lock occurs. Then again at position 3 if you observe here this pole, the third coil will be activated. The third coil will be activated by the supply and the second coil will be disconnected. And the connection and the supply positive and negative should be given in a such a way that there should be an attraction force between the rotor and the stator so that in what direction if current passes through that coil the attraction force exists between these both. So we need to analyze and we have to give the supply in a such a way. And the next, the fourth coil will be on and this coil will be off. Okay. So likewise, each and every coil will on step by step and off step by step. Okay. So that so this process is repeated in the same manner at the south and the west electromagnets until we again reach to the starting point. Okay, we will reach to this point again after completion of fourth point will come to the fifth point. So it will reach to the starting position point. So like that, this will be repeated and the rotor will start rotating with an angle of 90 degrees. Okay. So here we can observe there is a four steps. One, two, three, four. For completing a total 360 degrees. So understanding the resolution of this stepper motor, resolution in the is the number of degree rotated per step. Here, how the step angle will be given. Okay, the step angle is equals to 360 by n phase into phase, which is equals to 360 by n. So n phase is the number of equivalent pole per phase. Number of equivalent pole per phase and pH is a number of phases. Okay. So number of poles per phases. So n is a total number of poles per all phases together. So here, so we will see this, how this will be. The step angle is equals to 360 by the total number of the poles per all phases. Even that is also one of the formula for getting the step angle. So we will take one example so that we can understand better about the step angle. Okay. So here for a three winding motor with a rotor having four teeth and the resolution is 30 degrees. Three winding with a rotor having four poles. Okay. So 3 into 4, 12. So 360 by 12, then you are getting 30. Okay. So that is what the resolution is 30 degrees. So we will see the two-phase stepper motor. Okay. There are two basic windings arrangements for an electromagnetic coils in a two-phase stepper motor, that is bipolar and unipolar. Here A to B and A to B 1, 2. Okay. The rotor is a permanent magnet, only the stator. This is a unipolar and this is a bipolar. So what is the main difference? A unipolar stepper motor has two windings per phase, one for each direction of the magnetic field. And in this arrangements, a magnetic field can be reversed without switching the direction of the current. Whereas bipolar motors have a single winding per phase. The current in a winding need to be reversed in order to reverse a magnetic pole. Whereas bipolars have the high torque but need more complex driver circuits. So here stepper modes. How many stepping modes will be there? Okay. So wave drive on a single phase. So A1, B2 and A2, B1. So this is 25 percentage of unipolar and 50 percentage is bipolar. And full step drive. This is two phase on A1, B2, B2, A2, A2, A1 and V1, A2, A1. This is a 50 percentage bipolar binding and full bipolar. So 50% universal and full bipolar. And half step drive, single phase and two phase both. A1, B2, B2 and B2, A2, A2. So likewise, there are here three windings, two windings, say AB, AB, okay, A1, A2, B1, B2. So four windings in these four windings, which should be on, which should be off at what time. So that will give here the sequence. Okay, this is a single phase on, this is two phase on, this is single and two phase on. And micro stepping, the last one is, which is continuously varying my current motor currents. So the micro step mode drivers may split off a full step into many as 256 microsteps. So how many stepper motors are there? We know the stepper motors. In that there will be the classification of stepper motors again. So there are a variable reluctance motor, permanent magnet stepper motor and hybrid synchronous stepper. So as if now in your syllabus only to the types of the stepper motors, there is not the briefing of the stepping motors, types of stepper motors. Okay. So applications, where there is application, where the stepper motors are used. So the stepper motors can be a good choice whenever controlled movement is required. So they can be used to advantages in applications where you need to control rotation angle, speed, position and synchronism. So these include that in printers, plotters, medical equipments like fax, machines, automotive and scientific equipments, etc. So in these areas, the stepper motors are used. So the next is, so till now we have discussed about the stepper motor and the next is a commutator motor. So here, a three-phase induction motor is not a variable speed motor. Single-phase induction motor is not a self-starting motor and poor power factor emissions. Whereas common single-phase commutator motors are series motors, universal motors, repulsion motors, and repulsion induction motors. So AC series motors. If we connect normal DC series motor to AC, what happens? So we know about the DC motor. We have discussed about the DC motor. We studied about the DC motors previously. So we know how many types are there, and we know DC series motor. So for that series motor, instead of DC, if I apply to AC, what happens? We will see. So developed, the torque developed is not constant magnitude, and alternating flux induce eddy currents causing heat and thereby loss, and no inductive coupling between armature and field since they are placed in quadrature, and sparking in brushes is more due to the transformer EMF induced. So due to large voltage drop, speed reduces, and starting torque is low and power factor is low. So these all risks will be happen when we apply AC in place of DC for a series DC series motor. So what we have to do for AC series motor? Modification needed for AC series motor. That to reduce eddy current loss, laminations must be done, and to reduce reactance, series field should contain less number of turns, and to improve torque, number of armature conductors should be large, and to reduce reactance, compensating winding should be used, and operating voltage kept low for reduced inductance, and reduce frequency to reduce inductance, interpoles to reduce armature and resistance leads. Okay. So these are some of the modifications we have to do while making it as an AC series motor. So the next is a universal motor, that constructional details. So change should be employed to make in both an AC and DC. So universal motor is nothing but the motor which is running with AC and as well as DC without its performance effects much. Okay. So this is a motor, universal motor, AC flux, rotation and laminator, stator. So how the operation is there? We will see. When motor is connected to AC supply, the same alternating currents through the field and armature windings. And the field winding produces an alternating flux that reacts with the currents flowing in the armature to produce a torque. Since both armature currents and flux reverse simultaneously, the torque always acts in the same direction. So, it may be noted that no rotating flux is produced in this type of machine. The principle of operation is same as that of a series DC series motor only. Okay. Characteristics. The operating characteristics of a series motor are similar to those of DC series motor. First one is the speed increases to high value with a decreased in load. In very small series motors, the loss are usually large enough at no loads that limits the speed to a definite value, that is 1500 to 15,000 rpm, and the motor torque is high for large armature currents, thus giving a high starting torque. And a full load, the power factor is about 90 degrees. However, at the starting or when carrying an overload, the power factor will be lower. So applications where these universal motors are applicable. So the fractional horsepower AC series motors have high speed and corresponding small size, and the large starting torque. They can therefore be used to drive high speed vacuum cleaner, screwing machines, electrical shavers, drills, machine tools, etc. We observe The daily machines what we are using are mostly universal motors only. Okay. The single phase repulsion motor. So by the name only we can recognize by the action of repulsion the motor is rotated. So we will see. A repulsion motor is similar to that of an AC series motor except that. Okay, so construction and everything will be same. So except that the brushes are not connected to supply but are short circuited. So whereas in an AC series motor the brushes are being used for supply, but here the brushes are short circuited and the currents are induced in the armature conductors by transformer action, and the field structure has non salient pole construction by adjusting the position of short circuited brushes on the commutator, and the starting torque can be developed in the motor. See here. So the starting torque has been developed by the transformer action by shorting the brushes. So constructional. So the field of the stator winding is wound like the main winding of a split phase motor and is connected directly to the single phase source. And the armature or the rotor is similar to a DC motor armature with drum type winding connected to a commutator. However, the brushes are not connected to supply but are connected to each other or short circuited. This is to be noted, okay? That is only the difference. So the short circuiting the brushes effectively makes the rotor into a type of a squirrel cage. And the major difficulty with an ordinary single phase induction motor is the low starting torque. And it has also a better power factor than the conventional single phase motor. If you observe here, the two brushes are short circuited. The total armature torque in a repulsion motor can be shown, that is TA to torque is equal to sine of 2 alpha. So where alpha is an angle between the brush axis and the stator field axis. If the maximum torque, that is 2 alpha, should be 90 if alpha is 45 degrees. Thus, adjusted alpha to 45 degrees at starting, the maximum torque can be obtained during the starting period. However, alpha can be adjusted to give a suitable running speed. So, characteristics. What are the characteristics? The repulsion motor can characteristics very similar to those of an AC series motor. That is, it has a high starting torque and high speeds at no load. And the speed when the repulsion motor develops for any given load will depend upon the position of the brushes. And in comparison with the other single phase motor, the repulsion motor has a high starting torque and relatively low starting current. So repulsion start and induction run. See here. Sometimes the action of the repulsion motor is combined with that of an single phase induction motor to produce repulsion start and induction run. It is also called as repulsion start motor. So the machine is started as a repulsion motor with a corresponding high starting torque, and at some predetermined speed a centrifugal device short circuits the commutator so that the machine then operates as a single phase induction motor. So both will be operated. So we will call it as a repulsion start and induction run motor. So this motor has the same general construction of a repulsion motor, and the only difference is that it is equipped with a centrifugal device fitting with an armature shaft. Okay. So when the motor reaches 75% of full spinning speed, The centrifugal device forces a short-circuiting ring to come in contact with the inner surface of the commutator. So this will short-circuit all the commutator bars. Then what happens? The rotor then resembles it like a squirrel cage type of an induction motor, and the motor runs as a single-phase induction motor. So at the same time, the centrifugal switch raises the brushes from the commutator, which reduces the wear of the brushes and the commutator, as well as makes the operation quiet. So what might be the characteristics of a repulsion start and induction run? Characteristics. So the starting torque is 2.5 to 4.5 times the full load torque, and the starting current is 3.75 times the full load value. So due to their high starting torque, repulsion motor were used to operate devices such as refrigerators, pumps, compressors, etc. However, they posed a serious problems of maintenance of brushes and commutators. So repulsion induction run. The repulsion induction run produces a high starting torque entirely due to the repulsion after action. So, when running, it functions through a combination of induction run and repulsion motor action. Construction. The construction will be the stator and the rotor, and the stator carries a single distributed winding fed from single phase supply, and the rotor provides with the two independent windings placed one inside the other. The inner winding in a squirrel cage winding with rotor bars permanently short-circuited and placed over the squirrel cage winding is a repulsion commutator operating armature winding, and the repulsion winding is connected to the commutator on which ride short-circuited brushes. So, there are no centrifugal devices and the repulsion winding functions at all times. So, how will be the operation? So when a single phase supply is given to the stator winding, the repulsion winding is active. Consequently, the motor starts as a repulsion motor with a corresponding high starting torque. As the motor speeds up, the current shifts from the outer to inner winding. So which will, due to the reducing impedance of the inner winding, the increasing speed. Consequently, at running speed, the squirrel cage winding carries the greater part of the rotor current. So, the shifting of repulsion motor action to induction motor action, and it is thus achieved without any switching arrangements. So, here the characteristics of the repulsion induction motor. So, the no load speed of repulsion induction motor is somewhat above the synchronous speed because of the effect of repulsion winding. However, the speed at full load is slightly less than the synchronous speed, as in an induction motor. And the speed regulation of the motor is about 6%. The starting torque is 2.25 to 3 times of full load, which is lower value, being for a large motors, and the starting current is 3 to 4 times of the full load current. This type of motor is used for the application required where is high starting torque is required. So till now we have seen repulsion motor, now we will see the reluctance. It is a single phase synchronous motor which does not require DC excitation to rotor. Its operation is based upon the following principle. Whenever a piece of ferromagnetic material is located in a magnetic field, a force is exerted on the material tending to align the material so that the reluctance of the magnetic path that passes through the material is minimal. So likewise it will be operated. So construction is a stator carrying a single phase winding along with an auxiliary winding to produce a synchronous revolving magnetic field, and a squirrel cage rotor having unsymmetrical magnetic construction. So this is achieved by symmetrically removing some of the teeth from the squirrel cage rotor to produce salient pole on the rotor. So the salient pole created on the rotor must be equal to the poles of the stator. So note that rotor salient poles offer low reluctance to the stator flux and therefore become stronger magnetized. So how will be the operation? So when the single phase stator having an auxiliary winding which is energized, a synchronously revolving magnetic is produced and the motor starts as a standard squirrel cage induction motor and will accelerate to its synchronous speed. As the rotor approaches synchronous speed, the rotating rotor flux will exert the reluctance torque on the rotor poles, tending to align the salient poles axis with the axis of the rotor field. Here, so the rotor assumes a position where its salient pole lock with the poles of the revolving flux. Consequently, the motor will continue to run at a speed of revolving flux, that is at a synchronous speed. So when we apply a mechanical load, the rotor poles fall slightly behind the stator poles. So while continuing to run at synchronous speed, as the load on the motor is increased, the mechanical angle between the poles increases progressively. So nevertheless, magnetic attraction keeps the rotor locking to the rotating flux if the load is increased beyond the amount under which the reluctance star can be maintained synchronously. What is the characteristics of a reluctance motor? So these motors have four torque, power factor, and efficiency. These motors cannot accelerate the high inertial loads to synchronize speed. The pull-in and pull-out torques of such motors are weak. So despite of the above drawbacks, the reluctance motor is cheaper than any other. So this type of a synchronous motor, they are widely used for constant speed applications such as timing devices, signaling devices, etc. Though it has many disadvantages, only because it is cheap, it can be used. Okay. So hope today's session on the motors, that is special motors, understand is understandable. So we will meet in the next session. And till here we have completed all of our portion at the on the motors. So in the next session we will start all the networks. Okay. So you people, we have to keep on practicing on the subject so that you will get great. Fine. Thank you for listening the class.